Hi everybody, this video is going to be about the task 1.4 from Math 1, and the two learning targets we're going to be working on today are I can create a table or a graph for a situation that can be modeled as an arithmetic sequence, and I can create a table or a graph for a situation that can be modeled as a geometric sequence. Now we're going to focus specifically on tables today, and we're going to do this with arithmetic sequences. And we're also going to work on making tables with geometric sequences. Now, it's going to be really important today to understand the difference between an arithmetic and a geometric sequence, because that's going to help us create the table the right way. So as we go through these examples, one of the things that you should be thinking about is how understanding the type of sequence you're working with can help you reason through the problem. So for each of these problems on the first page of the notes, it says, given that the table is an arithmetic sequence, determine the missing terms. Now it's really important to read this carefully and to understand that having an arithmetic sequence tells us certain things about the problem. When we have an arithmetic sequence, we know for sure that the pattern that we have in the table is either adding by the same amount each time or subtracting by the same amount each time. Now that's important because our goal today is going to be to fill in this table, and the way we're going to do that is we need to figure out that if we start with 5 and then we're missing the middle number and we end with 11, how can we get there by adding the same amount or subtracting the same amount each time? Now, here are some things you should think about. Number 1, since the values are getting bigger in the table, so since the values are increasing, so we need to use a pattern of adding. If our values from the beginning to the end were getting smaller, I might think about using a subtracting pattern. And that's kind of where I would always start is what kind of operation should we be using? So since our values are getting bigger and it's arithmetic, we're going to be adding. Now here's where we might want to have a calculator out to help with arithmetic. You could use a calculator that's on your phone if you're at home, or obviously if we're in class, we will be happy to loan you a calculator. There are also free calculators available online. And one of the things that I would think about is, okay, if I'm getting bigger and I'm going up to 11, maybe we start by trying adding 2 each time. If I try adding 2, then the middle number would be 7. And if I add 2 again, the end number would be 9. Well, here's what that tells me. When I add 2, my end number is not what it's supposed to be. Therefore, since this number is too small, adding 2 was not enough. Next, I might try adding a bigger number than 2, maybe adding 3. If I add 3, I should get to 8. And if I add 3 again, I'm going to get to 11, which matches the number that I wanted to have. That tells me that the pattern should be adding 3 each time, and it tells me that the middle missing number here would have to be 8. These problems are really about deciding what operation we're going to use, and then guessing and checking and using our results to try to narrow it down to the correct table and pattern that we're filling in. So for problem number 2, what you're going to notice is that we're starting with the number 18. We're skipping a bunch of numbers in the middle. Our job is to fill all those numbers in, and we're ending with negative 10. This tells me that since our values are decreasing, which means getting smaller, so our pattern must be subtracting. Remember, if it's an arithmetic sequence, our option is add or subtract. In this case, subtracting makes more sense because the numbers are getting smaller. So let's try starting by subtracting 2. So if I subtract 2, then the next number would be 16. If I subtract 2, then the next number would be 14. If I subtract 2, the next number would be 12. And if I subtract 2, the next number would be 10. Now, 10 is not the same as negative 10. So since I want to become negative at the end, I need much smaller numbers as my answer, which means instead I might try subtracting 3. If I subtract 3, my answer is 15. If I subtract 3, my answer is 12. If I subtract 3, my answer is 9. If I subtract 3, my answer is 6. And if I subtract 3, my answer is 3. So even if we increase our number to 3, it doesn't quite work. We get 15, 12, 9. Oh, I think I did this one too many times. 15, 12, 9. Yeah, I apologize. I would actually have stopped at 6. I just didn't quite line them up the right way. Clearly 6 is not the number I was looking for, so I'm going to go even bigger. Let's try maybe jumping all the way up to, 5. So if I subtract 5, I get 13. If I subtract 5 again, I get 8. If I subtract 5 again, I get 3. And if I subtract 5 again, I get -2. We're getting closer. -2 is closer to -10. Let's try subtracting 7. So if I subtract 7, I get 11. If I subtract 7, I get 4. If I subtract 7, I get -3. And if I subtract 7, I get -10. So my missing numbers that I was looking for must be 11, 4, -3, and -10 because the subtracting 7 pattern worked. Now, there is no faster way to do this. It's really just about guessing and checking. If it doesn't work, try your best. You do not just try a different number that makes more sense. So for example, if you ended up with a number that was bigger than what you wanted, try subtracting a bigger number than you subtracted the first time. Let's try number 3. So we're going from 12 to -6. Because the numbers are decreasing, I'm going to use subtraction to try to figure out this pattern. So from 12 to -6, I'm definitely going to be subtracting. Let's start with, let's start with maybe 2. So if I subtract 2, I get 10. If I subtract 2, I get 8. If I subtract 2, I get 6. Subtract again, I get 4. Subtract again, I get 2. Subtract again, I get 0. Well, it's not quite what we were looking for. We were looking for our final number to be -6. So maybe now let's try subtracting 3. If I subtract 3, I get 9. If I subtract 3 again, I get 6. If I subtract 3 again, I get 3. If I subtract 3, I get 0. -3, I get -3. -3 again, I get -6. So that works out. That tells me that my missing numbers are 9, 6, 3, 0, -3, and then -6 we already have. For problem number 4, we're going from 40 to 10. Once again, our numbers are decreasing. Therefore, I'm going to think about subtraction. So, if we're going from 40 to -10, let's maybe try subtracting, let's go with 4 this time. So if I subtract 4, I get 36. If I subtract 4 again, I get 32. If I subtract 4 again, I get 28. If I subtract again, I get 24. And if I subtract again, I get 20. So not quite where we wanted to be. Let's maybe try subtracting 5. And again, this is just guessing and checking. You're going to maybe have to try a bunch of options. If you subtract once, you get 35. If you subtract 5 again, you get 30. -5 gives you 25. -5 gives you 20. -5 gives you 15. Well, we're closer, but not quite there. Maybe let's try 6. If you subtract 6, you get 34. Subtract 6 again, you get 28. -6 is 22. -6 is 16. and minus 6 is 10. Woohoo! We got the 10 that we were looking for. That tells me that my missing numbers are 34, 28, 22, 16, and then the 10 that was already there. Now, as a follow-up to this, let's talk about how we could change what we're doing based on the following instructions. It says, given that the table is a geometric sequence, determine the missing terms. Now, it's important to realize that a geometric sequence has different rules. Instead of choosing between adding or subtracting, we're going to choose between a multiplying or dividing pattern. We're going to choose multiplication if our numbers are increasing, and we're going to choose dividing if our numbers are decreasing. So let's go ahead and look at problem number 1. The first thing I notice is that this is an increasing pattern. We're going from 3 to 12, which means I'm going to use multiplication. Again, a calculator can be really helpful here, but let's just start by guessing maybe the number 2. If I multiply by 2, I get 6. And if I multiply by 2 again, I get 12. So we were lucky and that works. Now in the next pattern, we're going from 7 to 875. So that seems a little bit trickier. Let's maybe try, I don't know, the number 5. So if we multiply by 5, we get 35. If we multiply by 5 again, and I'm going to use a calculator, I'm really not kidding, that really does help. I'm going to type in 35 times 5 and I get 175. And I'm going to multiply by 5 again, and that brings me to 875. Woohoo! That was a lucky guess. I legitimately just guessed the number 5, and the only reason I did that is that the last number ended in 5, and I know that I can get to that by multiplying by 5. So that tells me the missing numbers are 135, 175, and then the 875 that was already there. Now for the next one, I'm going from 6 to 96. Once again, my numbers are increasing. So I'm going to use multiplication, which means let's maybe start with 2. So if I multiply by 2, I get 12. If I multiply by 2, I get 24. If I multiply by 2, I get 48. And if I multiply by 2, that gives me 96. So 2 works out here. We got really lucky on our first guess. If 2 hadn't worked, maybe the next one I would try is 3, depending on how 2 worked out. For the last problem, you're going to notice we have the first number and we have the second to last number. What that means is that after we find the pattern and we fill in the missing numbers, we're also going to take the pattern one step further to fill in the last box. Let's go, if we're going from 4 to 324, let's go with multiplication, because I see that I have an increasing pattern, which means I'm going to use multiplication. So if I go from, let's try 2. So 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. Now, I could try 3 next, because clearly multiplying by 2 did not get me a big enough number. So I could try 3. I'm actually going to try 4 next, just because I'm noticing that these are both even numbers, and so I'm thinking 4 might be more helpful. So if I multiply by 4, I get 16. If I multiply by 4 again, I get 64. If I multiply by 4 again, I get 64 times 4, which is 256. And if I multiply by 4 again, I get 1024. Well, 4 is too big. So what's a number in between 2 and 4 that I might try is the number 3. So if I multiply by 3, I get 12. If I multiply by 3, I get 36. If I multiply by 3, I get 108. And if I multiply by 3 again, I get 324. So that works out. Now if I multiply by 3 again, 324 times 3 would give me 972. So my numbers that I'm going to fill in are 12, 36, 108, and 972. All right. Thank you guys so much for watching. I hope that this kind of helps you think through the problems, gives you a strategy to use based on the type of sequence and whether the numbers are getting bigger or smaller. And then from there, it's really just a matter of guessing or checking and changing up your guesses based on the patterns that you're finding. Thank you guys so much, and I hope to see you soon.